Okay, hi everyone. This is Aaron. I just am going to walk you through the Wapuu smart contract. Best way to learn how to code, especially in a new language like Solidity or these decentralized app smart contracts, is to actually go over the code and kind of learn how it all works, look at other people's code. So that's what we're going to do here. So if I just pull up the smart contract on Etherscan, so the cool thing about Etherscan is it shows you kind of the state of any contract or address in the blockchain. So we can see just by searching for our contract address, which is public on our website, we can see some information about it. So we've verified the contract, which means we've confirmed the source code, so it's publicly viewable to everyone. And you can see all the source code for the contract files right here on Etherscan. So our main contract that we're using is this first one here, wapoos.sol. And we're going to look at that, but I'm going to go ahead and jump over into my code editor because it's a lot prettier there and I can zoom in for you. All right, so let's just walk through this. So first of all, smart contracts are written in a language called Solidity, and it's very familiar syntax to like C or PHP or JavaScript, so it wasn't too much of a learning curve for me, and I'm still definitely just a beginner, but it's pretty easy to get a good understanding of what it looks like and how it works. So the first thing is we choose what version of Solidity we want to compile the smart contract in. So the latest as of recording this is I think 8.7. So this is just saying anything 8.0 and above. Now, the most important thing for our contract is that it is a standard called ERC1155. So ERC stands for Ethereum Request for Comment. Essentially, it's kind of a standardization process. So if someone invents some new kind of technology that they think would be useful to have it standardized so that everyone could use it and it would be interchangeable between various applications and stuff like that, then they can do a request and for standardization and people can vote on it and all that. So one of the most basic functions of a smart contract is tokens. And what a token is essentially it's just a store of balance of something in a smart contract. So using tokens in a smart contract, you can use a smart contract to create your own basically forms of balance of whatever it is, voting rights, money, some other cryptocurrency, or even NFT, which stands for non-fungible token. So tokens could be either every token is worth the same thing. So a $1 token is worth and can be traded for a $1 token, and they're all worth the same thing, and they're all the same thing. Or you could have an NFT to where there's only one ever of a specific token, and each token is completely unique. And that's what the non-fungible part means. And so ERC20 is kind of our most basic smart contract standard for a fungible token. So that's usually what's used for things like other cryptocurrencies and stuff that are built on the Ethereum blockchain. And then they have standard, which was the first standard put forth for NFTs, and that's ERC721. And that's probably the most common NFT standard that you will see. And then a few years ago, a standard was proposed called ERC1155. And that is kind of the latest and greatest, newer smart contract standard that can be used for both fungible tokens and non-fungible tokens all in the same contract. So it makes it much more flexible. It was designed originally for creating games. So if you created a game, you might need to have a token that has say a balance of 1,000, and that's like your swords. And then you have another token that's a one-of-a-kind gun or rifle or something, and that might be a non-fungible token because only one of them exists. And then you can also, in the same contract, add another fungible token where you have 5,000 of some other item, for the game. So it gives a lot of flexibility to be able to store a lot more in the smart contract. And the other thing that ERC1155 is really useful for is that it's much more efficient. So in the original, most common standard ERC721, you're storing a lot of data. So you have to store data so that it allows you to find out what tokens an address owns, and vice versa, and all these other what they're called interfaces that allow you to find out more information about the smart contract and how it's working. So we went with, for the Wapuus, ERC1155 because of its efficiency. Mainly is we wanted this project to be more geared towards beginners in blockchain, and the gas fees are a lot less when you're doing things with ERC1155, especially when you're minting or transferring multiple Wapuus at the same time. You can save huge amount of gas compared to the standard ERC 721, because 721 you have to transfer or mint each thing individually, one after the other. And this contract standard 1155, it allows you to mint or transfer in batch, so you can do in one transaction, you can do a whole lot more, which can save a lot of money when it comes to minting or transferring ownership of an NFT. So I'll just walk you through this. So the first thing we do is we basically import some standards. So OpenZeppelin is kind of an open source framework for smart contracts. They've created some open source kind of frameworks for a lot of the standards that are out there, and a lot of common tools that are useful, like we're importing counters, and we're importing a tool called Ownable. Counters are simply make an easy way to have a number or a variable that can be incremented or decremented. So we use that to keep track of how many NFTs have been minted and how many there are and what the next token number will be. And then so we import these, and these can easily be pulled in via, in this case, we're just using npm to install them, and then we can import them here. Okay, now I'm going to skip over these little kind of libraries here, and we'll come back to those later. But here's the start of our main contract. So contract, we named it Wapuus, and then we are inheriting, it's kind of similar concept in object-oriented programming. We're inheriting the ERC 1155 contract, and we're inheriting Ownable. So this allows us to simply use those as a base and then just make some minor changes on top of it to customize our smart contract for our needs. And then I talked about the counters already. We're setting up a counter. The first thing we do is declare all our variables, basically, all the data that we're going to be storing. So we set up token IDs as a private variable, and that's just a counter that's going to count from 0 up to however many. Interfaces, we'll talk about that when we get to that part, but essentially these are a way that a smart contract can identify that it's compatible with a certain standard. So let's say another smart contract wants to talk to our smart contract, and they want to find out that if we support ERC 2981 standard, then they can call us, and then we can return the ID of that, basically, which says yes, we do support that. Okay, so some of the things that we added that are custom. Wapuu provenance. This is something that's totally optional, but some drops use this essentially, and basically what they'll do is it's just a text variable that's public, and we can save, say, once all the Wapuus are revealed, all 2,222, then we can essentially make one big image that's published to the IPFS blockchain that includes all of them, and create a hash of that image, and then we can save it here. So that way it's kind of a way that people can know or prove in the future what they all look like. There's nothing. This is beyond the normal specification of what is needed in NFT, but it's kind of a cool little thing to have. License, that's also something that's custom that we added just kind of on top of the normal NFT standard. It allows people to easily query what the license is for a given NFT token. In this case, Wapoos are GPL, and so they have to inherit the GPL license. And so we add this into the smart contract so that everyone can see it. And we actually provide later a way to change that license text if we need to, and then also a way that we can lock the license text. And once we've changed this variable to true, then it's impossible to update it anymore. And then I declare some variables for the price. So this is the minting price that we're going to charge, the fee to be able to mint a Wapuu. And this is the price for renaming Wapoos, which is a feature that we're going to release soon, hopefully. Also, we have a variable to save our basis points, basically the percentage royalty. So this is because we code into the smart contract a standard that's been proposed for royalties, and some online marketplaces they use this standard to query for when you transfer NFT how much the royalty fee should be for it and who it should be paid to. And I'll show you that in a minute. Max Wapuu purchase. So this is just an arbitrary number that we set to how many you're allowed to mint at one time. If you used our interface to mint a Wapuu, you see that it only allowed you to count up to 40 at a time, and that's enforced in the smart contract actually. And the idea behind that is to, if it's like really popular or everyone's trying to get in at the same time when the drop is released, that you can limit how many can be done per transaction and hopefully allow more unique people to buy them instead of just some whales, one or two whales buying all of them in one transaction. And here's probably the most important part. So this is how you know that we're never going to make more than 2,222 Wapoos. So otherwise, we could just allow you to mint them forever, but we've encoded into the smart contract an actual constant that can't be changed for the max token ID that can be minted. Sale is active. That's simply a way to turn on and off the sale. So when we first deployed the smart contract, we had it turned off by default, and that way no one could mint one, because it doesn't matter what's on our user interface. Like even if people don't have access to our website, they would still be able to see the smart contract on the blockchain and interact with it directly through scripts or through tools like Etherscan, like we showed you. Wapuu names. So it's called a map, and it's kind of similar to like an array or something in PHP or languages that you might be more familiar with. Essentially, we're just defining this as being an integer and a string. So the integer is going to be the token ID of the NFT, and the string is going to be the name of the Wapuu. So that starts out as basically empty, and if people choose to rename a Wapuu, then it will get written to this variable on the blockchain. Wapuu reserve. We reserved up to 50 for the team to be able to mint, and essentially that allows us to mint them only paying gas costs and to mint them before the contract is unlocked, before the public sale is unlocked. So it allowed us to reserve some ahead of time so that we could use them for contests and giveaways and things like that, like we've been doing. The OpenSea gas-free sale listing. So this is basically just hard coding a contract, and we're hard coding the contract address for the OpenSea marketplace. So OpenSea, by doing that, we actually, and that kind of goes back to what these functions are here: ownable delegate proxy, proxy registry, and those are all used as basically we override the approval function so that the OpenSea marketplace already has whitelisted approval, and that allows anyone who owns a Wapuu to be able to list it on OpenSea without paying gas fees. So that saves you a little bit of money if you want to sell your Wapuus just by adding that code to our smart contract before we deployed it. Okay. And now we define some custom events. Now an event is a concept in smart contracts that it wouldn't really be efficient to store like every like piece of data, like transaction or certain things that you want to notify, basically kind of like logs. It wouldn't be efficient to store those in the smart contract itself. It would be super expensive. And so it provides a way to publish an event that gets published to the blockchain kind of as a log. And so those events can be used to trigger like your front end, or trigger other contracts that are listening for it, or applications, Web3 applications. They can listen for those events, and they can index those events to be able to do stuff instead of having to read directly from the contract itself. So for example, OpenSea, whenever is always listening to the blockchain for the ERC1155 standard for whenever there is a minting event or a transfer event. And it's always listening to the entire blockchain for those specific kind of events. And when it finds those, then it registers them and indexes them into their application. So that's how the NFTs, once you mint, actually show up there. We don't have to use an API to tell OpenSea that it was created or anything like that, because they're listening for the events on the blockchain. So we added some custom events so that in the future, other applications or our application could listen for those events if we need to. Okay. And then when the contract is first deployed, you have a constructor. So the constructor, you can actually pass variables to it. So you can have like a generic contract, and then you have some constructor arguments that you use when you actually deploy it that are hard set into that contract. So we're not using any arguments. We are calling the constructor of the parent, the ERC1155 that we inherited, and that constructor takes as argument the URL for the metadata, which we'll talk about here. So probably the most important thing for NFT is when an NFT is minted, you don't actually save like the information about it or the image file itself into the smart contract, because that would literally cost hundreds of thousands, if not millions of dollars, because of how much it costs to write data to a smart contract. So instead, what you do is you implement, according to the standard, a URI function. So if I go, I'll just go here and look at the definition. So this is what the parent contract that we're inheriting is, and there's actually a URI function. I think it's towards the bottom, and it allows anyone to query, say for this token ID of this NFT, what is the URL that we should be looking for the metadata for it? Okay, here's a set URI, which is what we're calling before. I think it's inherited earlier than this. But the URI function, so all we're doing is calling the parent private function, and we made a public function here so that we are able to update that URI later on. Like say if we change the location of where our API is that serves the metadata, or if we want to put the metadata into the blockchain, then we can update that later, and that's what this function is. And that kind of brings us to another cool thing right here, Onlyowner. So Onlyowner is a modifier of the function, and essentially it comes from this ownable, which allows us to have very simple permissions for smart contracts. So essentially whoever deploys, whatever wallet deploys a smart contract, they automatically get set by the constructor as the owner of the contract. And because of that, we can set these modifiers on any public functions so that only the owner of the smart contract, only their wallet is able to actually call this. So only our wallet that created the smart contract is able to update the URI. and various other functions that are admin only, basically. So that's very simple permissions control. Okay, and we were talking about the whitelisting of the OpenSea marketplace. That's what this is happening for here. So we're overriding, the function from the parent contract, and we're simply saying if it's the OpenSea address, then we return true. Otherwise, we'll just call the parent function to whatever that says is approved. Withdrawal. So when people mint a Wapuu, they actually have to send a certain amount of Ether to our contract, and the contract functions as a wallet itself. And so this contract, it collects a balance as people mint, and the only way to get that Ether out of the contract, like to our company or whatever, to help pay our bills, is by us coding this withdrawal function. So very simple. Withdraw, only the owner can call it, and when it does, it checks the current balance of this smart contract, and then it sends a transfer pay request to the owner wallet. So payable message sender is the owner who sent this message, and then it transfers it to them over the blockchain. So it's a simple, like withdrawing from the bank, and that withdraws it to our wallet so that we can use it for other things. If you didn't have that, then those tokens would be lost forever. They'd be stuck in the contract and no one would ever be able to access them. Okay, total supply is essentially just in the ERC1155 smart contract for NFTs. They have this as a kind of default thing, but it's missing in this latest one. But essentially it just tells you what the current token is. So we can use that to get an idea how many have been minted. For example, on our homepage, when it says however many 500 out of 2,000 have been minted, it's actually just querying the blockchain for this public function, which returns an integer of how many have been minted. It's very simple, and we also use it for when we are going to mint a new one, how we decide what the ID will be. Okay. Now, and that's totally optional function. It's just useful that I added. And then balance of Wapuu. This is a custom one because I wanted to be able to check through other applications that we build. I want to be able to check, okay, this address, this wallet address, how many Wapuus does it own? So there isn't a standard to be able to do that normally in the ERC1155. In ERC721, there is one. And it's just called balance of address. But unfortunately, the balance of in 1155, it's actually saying balance of the address and the token ID, because each token ID could have a balance of more than one. It could be a fungible token. So essentially what I did is just created a wrapper of that, and then we have some checks. First of all, we make sure that they're not asking what the balance is of a zero address, and then we do a for loop through all the way up to the total supply, so from 0 up to whatever the latest number minted. And then for each of those, we check what the balance is for that address, and then we add that to our total balance, and we return that as an integer. It's very simple, but allows us to quickly see how many Wapuus a certain address owns. So if we want to use that later, for example, like access to some special deal or private function or whatever, we can just query to find out. And of course, we could do it ourselves on the client side by doing this loop on the client side and making a whole bunch of calls to the smart contract, but it seems a lot more efficient to be able to do it in the contract itself. All right, tokens of owner. So this is another kind of optional function that I added, and this allows us to quickly just return basically an array of what Wapuus a certain specific address owns. So that's another function that is missing in the ERC1155 standard, but it exists in the 721 standard. And so I just added my own custom version of it so that we could use that. Okay, so tokens of owner. It allows us to return a simple array of token IDs that someone owns. And we use that, for example, when we're returning the special editions to you on our website. So we'll query the blockchain for tokens of owner for your address. Then we get a list of all the tokens you own, and then whichever ones of those is a special edition, we can return via our API call so that we can list those. So this makes that easy. So it does highlight some interesting things that I learned. First of all, we do basically the same thing that we did before, is we get a count of tokens and that they own. And the reason that we need to do that is because to declare array, which is what I'm doing here, you have two options. You have the normal like array or map that you would normally declare. That actually has to be saved into the blockchain. So if you do that and try to do it a non-memory one, then what happens is that will actually cost gas to make this query. And it could cost a lot of gas. But we don't want that. We just only want to have it temporarily stored in the variable while it returns that data. So it would be completely gas-free because it's a read-only transaction. So the only way to do that is to declare the size of the array at the beginning. So you can't have an array that you could push items to of variable size. It's not possible to do that with a memory array for some reason. So we're declaring this array IDs, and then we tell it how many tokens it's going to be by doing that token count first, which tells us the size of the array. And then we kind of do the same thing again, looping through, and for each of the ones that they own, if balance of that token ID is 1, then we add it to the array. And then we increment the key because the keys have to go from 0 to whatever in order. You can't have a keys that skip numbers. So we have a key incrementer here so that you can just add that to the array. And then we return the array of IDs. So not too complicated of a concept. Here's where we really get down to it. So within the 1155 standard, there doesn't necessarily have to be any public interface for actually minting. So there is an interface that in this Open Zeppelin way that they did it, they created a mint and a mint multiple function, private function. Let's see. Yeah, there's mint, and then there's mint batch. That's what they're called. So essentially I created my own private function that's a wrapper of both of those, because those mint functions in themselves, they don't actually like keep track of which ID or anything like that. There's no enforcing of what it is, of what ID or how many there are. So this is a private internal function that we call via one below that we'll show in a second, but essentially we're passing the account, the address for the wallet, and the number of tokens. And so if they're only minting 1, then we'll call the normal mint function with the account, and total supply is whatever the next token key should be. So that's basically our incrementer. So it'll make sure that the next one you mint is the next token ID from 0 to 2221 because it's 0 indexed. And then 1 is hard-coded here. That's how many tokens should exist. I mean, how many should exist for this token. So remember, if it was a fungible token, you could say there's 100. So there's 100 of that specific kind of Wapuu, which we don't want. We want this contract to only be able to mint non-fungible tokens. So we hard code that to 1. And then there's a parameter that we don't use just for arbitrary data. And once we do that, we increment our token ID so that the next time it's called, total supply will be a different number. So that's pretty simple. Now, if we want to, if the user asks to mint more than 1 NFT, more than 1 Wapuu, then we do something a little bit fancier so that we can use the mint batch function. Because instead of just looping through and calling mint each time, it's actually much cheaper gas-wise if you use the batch function. So we do a similar thing to kind of what we did before, is we already know the number of tokens. So we can define two memory arrays of the IDs and the amounts. And then we can loop through the number of tokens that they want, and we can add the total supply plus an increment, so we know which token ID each one is. And then the amounts, it's always forced to 1 because they're non-fungible tokens. And then we call batch with our two arrays. So accounts, which is they're all the same address. IDs, which is, or account is the same address. And then IDs, which is an array of all the IDs from whatever it started through up. And amounts is always an array of ones. And that calls the batch function. And after we do that, we need to increment our counter. So we do that same thing, for loop, increment each time. So pretty simple, but this is kind of the most important function of the entire smart contract, because it's what allows minting, and it's what forces the minting to only be non-fungible tokens and to make sure that it increments the token ID each time. All right. Reserve Wapoos, this is what we talked about before, is for our staff or us to be able to, before it's public, to reserve a certain number of Wapoos. So you can see it's limited to only owner wallet can do it. And then we check that we're not reserving more than the 50. And then if we reserve it, it's not going to exceed the amount. And we actually subtract from that variable, the reserve, how many were reserved. And then we call the same function mint NFTs to us, or to whatever address we reserve it to. And this bypasses the minting fee essentially, but it only allows up to the 50 that was defined in the variable. All right. We talked about the provenance hash before. This is just a simple function that's only allowed by the owner, and all it does is update that string to whatever we want it to be. Flip sales state is the other thing we talked about. Only owner can call it, and basically it just sets the Boolean variable to the opposite of what it is. So if it's false, then it sets it to true. If it's true, it sets it to false. So it allows us to turn on and off minting for the public. Token license we talked about also. So if you pass it a token ID, then it returns a string that has the license text. So we are checking if it's a valid token, like if it's been minted yet. So making sure the ID is less than the total supply. And then we return the license text. Now let me just show you what that looks like. So on the on Etherscan, on a smart contract, you can actually interact directly with the smart contract here. So I can do read functions and I can write functions. So let's say read, and we said token license. So that's the function we were just looking at. And we can see the parameter here. So let's say for token ID 1, what's the license? It's always going to be the same, but it returns that string, GPL version 2. So you can see exactly how those functions work, and you can actually use them directly through Etherscan, directly on the blockchain, or total supply that we talked about. We can see the total supply right now is 556. Tokens of owner. All those same things. You can put an address to find out the tokens of owner. The URI, which we'll cover in a second. But let's say I chose the URI, and that would return that string that we had set before. So it's kind of cool to see how all this functions in real life. Lock license allows us to lock that license text so that it can't be changed again. And we see our change license function, and we can see that if it's locked, then it won't let you do it. It returns an error. And if it's not, then it sets the license text. Set mint price. This is a way that allows us to actually change the price for minting Wapoos. So that price variable that we declared that's public, we can actually, as the owner, can change that. So we can change it to whatever we want or make it lower, and then any new Wapoos that people try to mint, they'll have to provide that new price to be allowed to mint them. And then we have rename price, which is basically the exact same thing for when you want to rename a Wapuu. If you want to change the royalty function, works the same way, only allowed by the owner. And then we come to kind of a more important one, is mint Wapuus. So this is the public function that is used by our website and by anyone who interacts with the smart contract directly to actually mint them. So this is open to the public. It doesn't have like an only owner restriction. And then we set this modifier, which is payable. So payable means that a front end would make a pay API call to it basically and provide it with a certain value of Ether tokens. So to be able to interact with this function, you actually have to send some Ether along with it. So depending on the number of tokens. So we check some things that are important before we allow someone to mint a Wapuu. So we can say we require that the sale is active. We require that the number of tokens that they want is more than 0, and that the number of tokens is less than the max of 40. This message is wrong. The max of 40 that they could purchase in one transaction. And then we also require that the total supply plus however many they want to mint will be less than the max, which is 2,222. And we return an error if they're going to try to mint more than that, because obviously we can't allow that. And then we do some thing here where we actually check that the value of the message, this is the pay message that is sent by your wallet. We check that the value, the amount of Ether that is sent, that is equal to the Wapuu price times the number of tokens. So here's what we're checking to make sure you sent the exact right amount of money to be able to mint the Wapuus that you requested. And if you do it under, then it's going to throw an error. If you do it over, it'll throw an error. And that's nice of us because a lot of smart contracts, they don't check the over thing. So you could send it $1 million. They don't care. They'll take it, you know. And once all these checks check out, then we'll pass the sender address, whoever sent it, and we'll send the number of tokens, and we'll send it back to our internal private function to mint the NFTs. So this is really the core interface that people use to interact with the smart contract on our website. And we have some other things here, like this is having to do with the whole renaming function. So it works very similar, although we have permissions checks. So if you send a request that I want to edit the name for this token ID, and this is the name that I want, and I'm sending my money because it's payable, I can check that you actually own that token ID. If you don't, then we're not going to let you change the name. And then we check that the name that you're setting is the same. Is not the same as the one that's already set. So you have to do a kind of thing here because there's strings to be able to compare them properly. And then we also check the price that it matches up. And then once all that passes, we do the simple thing as writing to that map with the token ID, whatever the new name is that you provided. So that's actually writing it to the blockchain. And then we'll emit that event that we talked about, which is basically a log, so that we could set up an index later on. Say we wanted to have a thing on the site that updates or notifies people when someone's renamed a Wapuu, then we could always be listening to the blockchain for this event. And then once the names are set, we have a little function that makes it easy to be able to query the name instead of pulling the whole array. You can just pass in a token ID and it will return a string. So make sure the token ID is valid, and then it returns that specific name for one, which by default is empty. Okay, we're almost through it. Now we talked about the royalties before, so here are some of the functions for that. So for Rarible, they kind of set up their own standard for how you can define what royalties should be. So if someone sells one of these Wapuus on Rarible, then it will its smart contract will actually query and look for this method here, this function method, and passing it the ID, and then it expects a data format called libpart, and that's what we have defined up here at the top. So that I said we pass this library here, libpart, and I just took that from their example code. Very simple, and using their example code from their own contracts from Rarible, I basically just made it so that no matter what the token ID is, we basically ignore that ID. The reason I have it commented out is so that it won't cause a compile error, saying that we're not referencing that ID anywhere else. And then we just manually set what the royalty should be and who it should be paid to, the owner address, and return that libpart array or whatever it is to people. And then Mintable and probably other NFT marketplaces, there's actually a new standard that was kind of certified just a few months ago, and that's called ERC1155 And so before, there wasn't any standard for defining what royalties should be when an NFT is traded on the blockchain. So it was really up to every individual marketplace how they wanted to implement royalties. So for example, OpenSea, you just prove that you're the owner of the smart contract, and then they'll let you set a royalty manually on their website. But this is kind of the new standard, and probably a lot more marketplaces are going to start using the standard, and it's made to be really flexible. And essentially all it does is it creates a method called royalty info. And it takes a token ID and the sale price, or what it was sold for, and then it returns the receiver who should receive the royalty and how much they should receive. So you can do any kind of calculations here that you want to make your specific NFT royalties work the way you want to for anyone that follows the standards. So we're returning always the owner of the contract to be the receiver of royalties, and then we're taking the sale price that they passed us and multiplying it times the basis points that we defined above, and that's editable by the owner, and then divided it by 10,000. That's just so the basis points returns like an actual percentage, which they expect for royalty info. And then we also mentioned the interfaces. So we define these different interfaces. So those custom interfaces that we defined, basically this is the standard. So if another smart contract wants to see if we support this or if we support this, then before calling these and causing an error, they'll actually call supports interface, and that will return either true or false. And so we have some overrides here. We're overriding. So if it meets this standard here, then if the interface that they're calling meets that, then we return true. If the standard for ERC1155 if they're calling to see if it's compatible with that, then we return true. Otherwise, we just go up to the inherit from the original contract. So yeah, that's our entire smart contract. Pretty crazy. It's not too hard to understand, I hope. It just takes trial and error and all that kind of stuff, and just showing you some examples of reading the data from the smart contract. So I can see the sale is active now, royalty info. So let's try that out. So let's say that it's token ID 1 and the sale price was, I don't know, query, yeah. So let's see how it returns the receiver address and returns the amount of calculated royalties. So you can see kind of exactly how all those things work. If I want to say balance of Wapuu, well, I need an address to put in there. So writing the contract, if you want to write to a smart contract directly on Etherscan, you can actually connect your Web3 wallet, and then you can actually do things directly through here, so you don't have to create a front-end interface even. So if I want to update the license text, I could actually update it, and then it would query me for whatever. So let's say I just put some random text. I said I want to write that. I can see it actually prompts me to do the transaction, and it's going to cost me $10 in gas to do it if I want to update the license text to that, which I don't want to. But you can see how you can do all that right here on the blockchain. Or if I want to change the name of a Wapuu, I can choose how much I want to pay, which is going to be whatever the price is set. The token ID I want to change, and then whatever the name is that I want to add. So yeah, you can do all that by writing directly to the blockchain, which is pretty cool, I think. And I know that we talked about events and stuff like that. You can also see here in Etherscan all the transactions as they happen. So I can see the methods that were called. Mint Wapuu's method was called. And we can see what the value that they sent was. And then more, you can dig into transaction details. And then events are also here as well. All right. Thank you for your time.